Okay, let's go to the wave simulator and try to simulate another wave that I'm gonna suppose. Let's say, and this is left over from last time, let's say that we want to do a group velocity that's undefined. A group velocity that's undefined, but a phase velocity that is non-zero. A phase velocity is non-zero, so the group velocity, remember, is delta omega over delta k. To make it undefined, then delta k should be 0, and so that means that k1 should equal k2. So I'm going to make k1 equal to 8, and omega 1 equal to 8, and k2 equal to 8, and omega 2 equal to 7, because we don't want it to be 0 over 0. We want it to be a finite number over 0. I'm not sure that matters, but anyway. So what I've chosen here is, oh, I hit enter, so you get to see without thinking, that the delta k is 0, so that means the group velocity is undefined. The group velocity is undefined, but in this case, the phase velocity is still non-zero. So what do we get? Is we get something that shows no groups because the group velocity is undefined. So that means that if the group velocity was 0, we would have a group that sits still. If the group velocity is non-zero, it's going to move. But the group velocity being undefined, no group. What happens when time goes on? Ah, can you imagine what happens when time goes on? I bet you can't, because I bet what you're thinking is that one of these peaks is just going to be moving along. That is not the case. All right, what happens is the peaks move along, but they get smaller and bigger. Peaks move along, so the phase velocity is this velocity here, trying to track it. Phase velocity is the velocity of a peak as it goes. There is still a group, is just an infinitely long group, so you can't see the envelope because that group velocity is undefined. So it's still getting smaller and bigger as time goes on.